Next, we'll have Jujiao Kang from Fudan University, who's going to tell us about some exciting burgeoning field of proteomics and using UK Biobank paired proteomic and imaging data.
Thanks for the introduction. Good afternoon, everyone. I'm Jujiao from Fudan University. I'm very glad to be here to present this work to you in this fabulous meeting. And the title today is Plasma Proteomics Identifies Proteins and Pathways Associated with Incident Depression. Let me start from some background. Depression is a growing global concern with a high prevalence, high risk of recurrence, and a heavy disease burden. The mechanisms of depression is very complex, involving multiple biological processes, such as neurogenesis, neurotransmitter, neuroimmune, and neuroinflammation processes. Understanding these mechanisms is crucial for developing more effective drug targets. Proteins as the end products of gene expression are essential for the cellular function, and they can provide direct insights into the disease mechanisms. And also, the majority of the drug targets are the proteins, and the blood is easily accessible and routinely used in the clinical diagnostics. There are several peripheral markers of depression, such as inflammatory and growth factors and others. However, we still need more information on whether the changes in plasma proteomics can serve as the early biomarkers of depression. While several studies have explored the associations between plasma proteins and depression, their findings are often limited by small sample size or restricted proteomic coverage. And many studies are cross-sectional, which may introduce reverse causation. There is still a need for a large-scale plasma proteomics study on depression. Therefore, we use the plasma proteomics data from UK Biobank to identify the proteomic signature of depression and understand the mechanisms and inform the tailored treatments. Here is our study design. We use the data from approximately 50,000 adults from UK Biobank with 2,920 proteins for analysis, and depression diagnoses were identified using the ICD-10 codes F32 and F33. We then examined the associations between these proteins and the incidence of depression. And then we explored the association mechanisms by testing the associations between these proteins and the brain structure and genetic risk and environmental factors. And finally, we characterize the biological function of these proteins using bioinformatic analysis. First, we try to find out which plasma proteins were associated with the depression. So we examined the associations between plasma protein levels and the incident depression using Cox proportional hazard regression model. And we identified 157 proteins were significantly associated with the depression, and the majority of the proteins were positive correlated. And the top associations were growth differentiation factor 15, and followed by gastrin and others. And in addition, the majority of the proteins were validated in an independent sample from UK Biobank. For the external validation, we used the summary data from a previous proteomics study, which examined the 120 proteins. And 14 proteins were associated with the depression at a notable significance level. And we then examined the associations between these proteins and the depression severity scores. And the depression severity scores were measured by the Patient Health Questionnaire 4 and 9. And we found that nearly all of the proteins were associated with a baseline depression severity score. And the majority of the proteins were also associated with the follow-up depression severity score. And all the proteins remain significant associations with the incident depression after the adjustment for the baseline depression severity score. And these results demonstrate that these proteins showed a long-term association with the depression beyond their baseline association. We then try to understand the associations between plasma proteins and the depression. First, we try to examine whether the proteins were associated with brain structure. So we first examined the associations between these proteins with the global brain measures, including total brain grammatical volume, cortical and subcortical grammatical volume, and white matter hyperintensity volume. And we found that 60 proteins showed associations with the global brain structure measurements. And higher levels of the GDF-15 and others were strongly associated with a lower grammatical volume. And a higher level of NEFL showed the strongest association with a larger white matter hyperintensity volume. We then examined the associations with these proteins and brain regional measures. And we found 18 proteins were related to brain regional measures. And the proteins, including Breivik, GDF-15, and others, showed significant associations with at least 10 brain structures. And the regions, including left middle temporal gyrus, left middle orbital frontal gyrus, bilateral thalamus, and hippocampus, and anterior thalamic randomization, and others were included. We then try to find whether the associations between plasma proteins and the depression are driven by genetic or environmental factors. So we examined the associations between genetic risks and the proteins. Although we find 23 proteins were nominally associated with polygenic risk scores of depression, none of these proteins were survived from multiple correction. And we then examined these associations of these proteins with stress-related events such as childhood trauma, adult trauma, and self-harm experiences. And all the stress-related events were associated with the proteins. And 8 proteins, including the gastrin, were associated with more than 5 items. And then finally, we try to characterize the biological function of these depression-related proteins. First, we conduct a pathway enrichment analysis, and we found that the proteins were enriched in immune-related pathways. And we then explored the up-regulators of the proteins and found 9 transcription factors related to the immune and inflammatory responses. And the protein and the protein interaction analysis found that the proteins showed a high level of interconnectedness. To summary, this study observed a substantial association between 157 proteins and depression. And nearly half of these proteins showed significant associations with the gray matter volume and white matter tracks. And protein alterations were linked to stress-related events. And the bioinformatic analysis highlighted the immune-related pathways involved in depression pathogenesis. An acknowledgement, I would express my sincere appreciation to my supervisors, my collaborators, and the fundings, and the open data resource. And that's all. Thanks for your attention.
I think we have time for one question, because I'm running a bit behind.
Thank you very much for your presentation. It's a very wonderful work. And I have one question. As you show on your PowerPoint, I saw that you do validation. You do validation in the independent cohort, but you also, as I saw, you also use UKB data. So I want to know, how do you do validation analysis? Could you make more details?
Yes, thanks for the question. Actually, in the main analysis, we excluded the participants which diagnosed with a depression before or at the baseline, which means they take part in the UK biobank. And then in the validation analysis, we include the participants and compare the protein levels between these participants with the existing depression diagnosis and the controls for this validation.
Yeah. Okay, thank you.
Thank you.
Thanks so much, Jujiao.